All right, good day and welcome back to chapter 21, reflection of light from spherical surface. First things first, jot down. A convex mirror always produces a diminished erect image. Next line, right. All erect image are virtual. All erect image are virtual. Next, right. The focus of a convex mirror is behind the mirror. Hence, both image and focus are virtual, and both image and focus are virtual. And a virtual focus is negative. A virtual focus is negative. I want you to also jot this down. Convex mirror. The object distance, the object distance is always positive, while the image distance is always negative. The focus is always negative. The focal length, right? Focal length is always negative. The focal length is f, always negative, and its magnification is less than 1 or diminished, less than 1. Next, right, concave mirror. The object distance is always positive. The image distance is either positive or negative. The focal length is always positive, while the magnification depends on the object distance. Alright, they say which of the following is true for the image formed by a convex mirror. For convex mirror, the image and the focal length are negative. Only the object distance, that is positive. So the image is always virtual. That's the number one. Let's see. Image is always virtual. Image is always erect. Image is never magnified. Okay, it's never magnified. Sure. The focal length is negative. Makes sense. And let's see. Option E, all five. For convex mirror, write this one. Always virtual, erect, and diminished or never magnified, and focal length is negative. The image length is also negative. Image distance is also negative, while the object distance is positive. So number one is option E. Number two has to do the calculation. Number three, please note the calculation series is done separately, so we could interact much more on that. Number four, which of the following statement is applicable to a real image formed by a concave mirror? Don't forget, for concave mirror, both the object, image, and focal length are all positive, and magnification depends on the object distance. So it's going to literally be almost like the opposite of convex. So which of the following is applicable to a concave mirror, right? Write down. A real image is always formed. Next line, the image is inverted and can be captured on screen. Next, the image is formed in front of the mirror. Front of the mirror. And lastly, concave mirror is a converging mirror. Concave mirror is a converging mirror. So number four, let me see it through. It can be observed on a screen. Call it correct. It is always inverted. Yes, so and it's formed by the actual converging rays of the light. Option B. Number four is option B. Number five. In order to produce a parallel beam of light, a lamp is placed at a distance from the concave mirror equal to, number five, equal to half the radius of curvature. Equals to half the radius of curvature. Option B. Next, for a concave mirror to form a real diminished image, the object must be placed, number six, at a distance greater than the radius of curvature. Option E. Now let's take down short note here. Right. Image in concave mirror. Image is in concave mirror. First, right, the object is beyond the object is beyond the center of curvature. and it's diminished, comma, inverted, and real, real. Continue. And it is formed in front of the mirror between the center of curvature and the principal focus. Center of curvature is represented with capital letter C. Principal focus is represented with capital letter F. Next, when when the object next when the object is at C, which is center of curvature, the image is inverted, real, and the same size as the object formed at C, and the image is in the front of the mirror. Just write it like that first. Might not make much sense to you for now. Just jot it down for me. Number three, when the object is between the center of curvature and the principal focus, the image is enlarged, comma, inverted, comma, real, and is formed in front of the mirror beyond C. Next, when the object is at F, which is the principal focus, the image is magnified, comma, inverted, comma, real, but formed at infinity, but is formed at infinity. And lastly, when when the object is between the principal focus and the pole of the mirror is represented as capital letter P. When the object is between the principal focus and the pole of the mirror, image is magnified, virtual, erect, and formed behind the mirror. Formed behind the mirror. So number 6. For a concave mirror to form a real, diminished image, the object must be placed at the distance greater than the center of curvature, greater than the radius of curvature, option E, greater than the radius of curvature. The object and image distance of a converging concave mirror are related by the equation. 7 is option C. They are related by this equation. Here is the graph. You see with the graph, they are related by this by this graph here, where the M stands for magnification. Magnification equals V, which is the image distance, over U, which is the object distance. Here, 8 has to do with calculation. 9, a convex mirror is used as a driving mirror because convex mirrors are used as driving mirrors. Don't forget to, because a convex mirror, that's number 9, Abi, is used as a driving mirror because, let's see, a lot of this thing here, okay. Its image is erect, option I, and it has a large field of view, option B. Number 9 is option B. The reason they use convex mirror for driving, the image is erect and you can see a large area. A dentist has the calculation. A pencil is placed vertically between a concave mirror and its focal length. The image of the pencil in the mirror will be virtual, erect, and enlarged. Option D. 11 is option D. Virtual, erect, and enlarged. Virtual, erect, and enlarged. 14. So that's the calculation. 15. Which of the following properties make the convex mirror useful as a driving mirror? This question is repeated. Convex for driving. The image is erect and we can use it to view a large area. Option C, II and III. 16. When an object is placed very close to the pole of a concave mirror, the virtual image obtained is enlarged and upright, option D. 17. 18. Which of the following expression gives the linear magnification produced by a concave mirror of radius of curvature R if U and V are the object and image distance respectively? There's a little bit of manipulations here to solve out, but you get M equals 2V, then R minus 1, something like this. 18 is option B. 19. To produce a parallel beam of light from a concave mirror, the distance at which the lamp should be placed from the mirror is equal to 19. The two times the focal length. Option B. 20. Which of the following graph represent the relationship between M and V for a converging mirror? Is option D. This one here. Option D. 21. A real object is placed at a distance u centimeter in front of a curved mirror of focal length f centimeters. If the image is upright and magnified, then that mirror would be concave, and the object distance over 2 equals the focal length. Object distance over 2 equals the focal length, which is option D. They say a real object is placed at a distance in front of a curved mirror of focal length f centimeter. If the image is upright and magnified, option D, concave, and the focal length will be equals to the u over 2. A boy is looking into a mirror. Observe that his face appeared to have grown bigger. The boy must have been looking at a concave mirror with his face between the focus and the mirror. A concave mirror with his face between the focus and the mirror. Whenever your face is between the focus and the mirror, it looks enlarged. This happens in a concave mirror, not convex. So 22 is option B, concave mirror. An object O lies at a distance m in front of a concave mirror of focal length f. If the magnification is less than the focal length, then the final image obtained will be magnified and erect. 23. The final image will be magnified and erect. The object lies in front of a concave mirror of focal length f. If the magnification is less than the focal length, that's magnified and erect. The most suitable type of mirror used in construction of a searchlight is parabolic mirror, right? Parabolic mirror produces strong parallel beams, and they are used in searchlight. 24 is option D. 25, okay. 26, 11, 27. To produce an enlarged and erect image, with a concave mirror, the object must be positioned beyond the center of curvature. Option C. Beyond the center of curvature. 28, that's the calculation. 29. At what position will an object be placed in front of a concave mirror in order to obtain an image at infinity? Between the principal focus and the center of curvature. Option B. What types of mirror are capable of producing parallel beams of light, such as those arising from the headlamp of a car? Parabolic mirrors, searchlight. An object is placed 10 centimeter. There's a calculation there. There's a calculation there. Convex mirror are used as driving mirror because they are erect and they cover a large distance. But this time around, notice the question here, it's slightly twisted. Now I want you to jot down something for me. Concave mirror equals converging mirror. Convex mirror equals diverging mirror. Next, right. Concave lens equals diverging lens, while convex lens equals converging lens. We'll touch this on the subsequent chapters. 34 is option A, erect, virtual, and diminished. 34 is option A. An object, okay. Calculate. So where can the man place his face to get an enlarged image when using a concave mirror to shave? Between the principal focus and the pole. Option C. Or the mirror. They'll say principal focus and the mirror. Or between the principal focus and the pole. 39. After the reflection from a concave mirror, rays of light from the sun converges at the focus. You converge at the focus. 40, 41. Okay, this is the last one. Convex mirror is used as a driving mirror because it has a wide field of view. 42 is option C. Don't forget, it's always erect also. We've gotten to this point. Well done. The purpose of this clip is to first build acquaintance, and the short note given to you, I'd like you to snap and send the note to the group where we'll do a proper drill. And more explanations also will be given in areas that are grey for you or you do not understand. If this is your first time coming across our video, please note that we run classes. If you'd like to be part of the class, you could also use the link in the description box of this video to join in, and so you can enroll and get started. Thank you for watching. I'll see you in the next one. If this is your first time here again, do well to subscribe. Click on the subscription button and just drop a like. It will go a long way in helping us. Thank you.